Bem-vindos, pessoal de casa. Welcome. So today we are here on a new edition of the IndustrialPOD, Alutal podcast, which we like to show people industrial stuff, stuff related to the automation, to the engineering, to the instrumentation. And today we have a very special guest coming right from Europe to our podcast is Mr. Marcel from M&C firm. So welcome, Mr. Marcel. Thank you very much for coming over.
Thank you very much for the invitation. Very excited.
Nice. So first of all, what does M&C do? And how is your experience and background on this instrumentation and analytical industry, please?
Yes, thank you. M&C TechGroup Germany, as you rightfully said, we are a German-based company and we are specialized in a part of an extractive gas analyzer system. There are many analyzer suppliers around the world, and we don't look too much at the analyzer aspect of the extractive analyzer, but we are looking at the sampling and the conditioning, while we say that the most important part of a gas analysis system is not so much the analyzer, but it is all about the sampling and the conditioning system. So this is what we have been doing for the last 40 years. This year is also a big event for us. We will be celebrating our 40th anniversary.
Congratulations.
Thank you. And you're invited for the party.
Of course. Thank you. So when you say sample conditioning is as much or even more relevant than the analyzer itself, for someone who is new to this science, why it's so important to handle the sample that carefully?
Now, it is if you look at the analyzers and the way they are produced, these are very clean machines. They are also produced in a very clean environment, and then we take these very clean analyzers that can use clean gases, and we bring them into the industry where the gases are not clean. They're dirty, there's a lot of dust, there's a lot of acids inside, the temperatures are high. And in order for these analyzers to keep working as they should work, we should bring the temperature down. We should take out of these dust particles, we should lower the acid content, we should lower the dew point. And if you don't do that, the analyzer will not live very long to take a shortcut. So we basically make sure that the selected analyzer will work for 15 to 20 years.
Understood. So when you are handling this sample, like cleaning it and making it more stable for the measurement, is not a risk of you make the sample contaminated, or you change the real value of that sample? How do you do for this that do not happen?
Thank you for asking. Of course, sampling and conditioning should not affect the gas composition. And therefore we say that sampling and conditioning should also be made on the customer application. For instance, a lot of our products are being used in continuous emission monitoring systems, and basically every industry has one or two or more stacks, and nowadays these stacks have to be measured continuously. Some people say, yeah, but SEM is a very easy application. When it goes out of stack, it's quite clean. And basically, you are right, but the gas composition of a cement plant is very much different as the gas composition coming from a waste incinerator or a gas-fired power plant. And even within the same industry, I've seen it myself, cement companies using, let's say, natural gas as fuel. But some of these cement companies can also be using a secondary fuel. And for instance, I've seen cement plants using burning tires as secondary fuel. And you can imagine that this changes the gas composition completely. And so we have to look at the application on its own, and we have to design the sampling and the conditioning in such a way that it doesn't influence the gas composition. Because in the end, you want to have your measurements, and you want to have your measurements accurately and for a very long time.
Mm-hmm. Yeah, thank you for explaining, because this is something that It's not the natural, right? When you think about analyzing something, you first think about the analyzer. But what you're saying is that if we doesn't handle the sample correctly, your analysis doesn't work. Nothing.
I even dare to go so far that it doesn't matter what analyzer you choose. There are no bad analyzers in the world. Most of the companies have been in business for 40, 50 years. Now, if they would have made wrong or bad analyzers, they would not be in business.
Okay.
These analyzers are good. Assumption is that approximately 50% of the continuous gas analyzer systems in the world are not working well, or maybe even not working
50%.
at all. 50%.
Wow.
And this has to do with the sampling and the conditioning. It has nothing to do with the analyzer. And that is, I think, an important lesson that we should tell to the industry, to our end users. Don't focus on the analyzer. Start designing your gas and your gas sampling and your conditioning system, and then make the choice for the right analyzer.
Yeah. So getting back to the history and the first steps of the continuous emission monitoring systems. So this is, I guess, probably something new, right? I would say maybe mid 80s, when it has started, like when people started worrying about what they are putting out from the stack, and how does it M&C company have saw this such an opportunity on this business?
Yeah, it is even longer ago. I think it is safe to say that the US was the first, and they didn't start with emission monitoring. It all started with ambient air monitoring, measuring the quality of the air that we breathe in as human beings. And after that, they said, yeah, but if this air is not clean, where is it coming from? Oh, it's coming from the industry. We should measure the industry. And this is basically how the whole emission monitoring started in the US. And this came over to basically to Europe. And the good thing is that in the US, the market mainly started with ambient air analyzer technology, as I told you. And in order for them to be measuring in the stack, in chimneys, the concentrations were much higher. So it meant if we want to use our ambient air monitors for these higher concentrations, we have to dilute our gas. This is how dilution came into the EPA, and this is now also an allowed method in the US. Where in Europe, they only started when emission monitoring came in. So if you look at the German, European companies in the analyzer technology, they don't have ambient air. They only have emission monitoring analyzers. This is also why dilution technology in Europe never became popular. But it's safe to say that the US was the first, starting measuring the ambient air quality and then finding the reason why is this ambient air maybe not as clean as we thought. And that led eventually to emission monitoring in the industry.
Okay, got it. So nowadays, what have changed on regulations and into the technology from the initial phase of these instrumentation controls to nowadays? What have changed? Has any analyzer evolved to a point that there's no need of sample conditioning, or is less dependent, or how do each part of the system evolve among time?
Yeah, it's good that you ask. Our industry is a very old-fashioned, slow-moving industry. And so basically the technologies that are used nowadays are almost the same as the technologies that were used 40, 50 years ago.
Wow.
We are still using NDIR, NDUV as methods to measure different gases. What changed a little bit is that slowly also lasers are being used nowadays. The good thing about laser technology is that they are very selective, so you can really focus on one component, and you can use this technology directly in your chimney. So you do not need to have this sampling and conditioning anymore. You can basically mount the transmitter and the receiver directly on the chimney to do your measurement. But as I said, we are a traditional industry. Customers are also very traditional, and they like to keep using extractive gas analyzer technology. And we have seen lasers came in. It's not a new technology yet. It started 25 years ago. But we also said, wow, what will this mean for our business? We are only in extractive business. And it never hurt us. Our business only grew. So yes, laser technology was a new technology. In situ was a possibility. And what you see now happening is that people like to use the lasers, but not directly in situ. They now take the lasers and use them as an extractive analyzer in combination with our sampling and conditioning.
Controlled conditions.
Yeah. So for us, the market only grew with the new technology that came into place.
So I know that M&C company sells all over the globe. So getting from one region and one country, one continent to the other, how does regulations play important role on the obligation or have a better SAMs, or doesn't have it, or the liabilities of not controlling it? How does it work? Which will be today currently the world model for such industry, and what the different regulations have in common and in difference?
Good question, long question. In the end, it is all about protecting the environment by measuring what goes out of stack. But we have to be realistic. Starting with emission monitoring technology is something the industry doesn't want in the beginning. It doesn't bring them any money. It's end of pipe. You only register what goes to the environment. And based on that, you have to pay money. So what you typically see happening in a relatively new market is that the customer wants to have the cheapest available on the market just to satisfy the legislator. This is the only reason that they want the system. It's costing them money. So is this wrong? No, this is like a normal phase to go through. And eventually this emission monitoring market in each country, they will mature, meaning the legislator will be more strict. He will control much more. After a customer gets a penalty because the analyzer system is not working well or not working at all, the customer says, maybe I should invest this money instead of paying fines. And if you see now in let's say, the more matured markets, let me say the US and Europe, there it doesn't really matter anymore what the costs are of an emission monitoring system. It is they need a system which will work as close to 100% as possible, which will give them reliable results. And these results he can present to the legislator, so he can keep on producing, because legislators slowly will get more powerful. Fine. And eventually they could even stop you from producing if you don't live up to the legislation.
Sure.
So, and that's the interesting. You see countries starting, you see countries being at the top of the list, and everything in between.
And I don't know, because in Brazil it doesn't live yet such reality, but some places they are selling carbon credits based on how clean and how green they could produce. Does SAMS is a tool for that?
Yeah, of course, that would be the perfect tool. Nowadays, you have to buy for your CO2 emissions. So this costs money. And if you can prove that you used less, then you're able to sell that part that you used less to your competitor. That could give you the possibility to be better in price. You can reduce your price because your competitor is not producing in a very clean way. So when that really starts to work internationally, then people will definitely start installing more and more SAMs, and that will also eventually result to cleaner production and less emissions. So the future is looking bright for that matter.
Yes. I think humankind urgently needs to pay attention on our natural resources, right? We just have the idea of how we are using the road resources when we see some documentary or some stuff, some bad stuff. But nowadays it's almost impossible to walk around the beach and doesn't see plastic floating all over, right?
Exactly.
Yeah,
The environmental is something we should cherish, and one of the things is measure your emissions in the right way, and getting an awareness at the industrial customers that they should reduce as good as possible.
Do you personally see any impact over the new legislations or the new industry requirements over this new wave of denying the global warming or stuff like that? Or you think this is just something that will pass and people will understand that this is serious stuff? What is your personal belief?
My personal belief is that it does matter. CO2 emissions will cause us problems in the future, and it will create global warming. So we should take every step possible to reduce this. And it's not just the industry, but it's also in the cars driving around. Nowadays, I'm not sure what is happening in Brazil, but in Europe, I think at least 50% of the cars that are being sold nowadays are electric cars. I'm not 100% sure if the whole environmental balance is okay, but at least the exhaust pipes of these electric cars are extremely clean nowadays. So every step that we can take, we definitely should take.
Yeah. Indeed. So getting back to the more technical stuff related to the quality of the sample conditioning and etc. You have mentioned before that more or less 50% of the whole road installations on SAMs are not working properly or even not working. So let's say we are speaking with a user that is on his industry and that he knows this is happening with him. So what would you recommend as a first step to change this on a way that he could bring this idea to the management and he will approve something that maybe they have already invested and so on? What you think will be a good way to start looking over this?
Yeah, good. Now, this is work. This is hard work, because what you basically have to do is you should go on location. You should go meet your customer, sit down with this customer, and try to find out what the problems are. Is this filter blocking? Is it blocking because of dust? Is it corroding because of acids? Where is his dew point? What about the dew point after the cooler? The system is not running for a reason. We have to find out what the reason is, then have a look at this industry, have a look at this gas composition, and then try to come to a conclusion. I always say fixing a system is something you must do together with your customer. Your customer knows his process. He also knows what materials he's using inside of his process. So if the materials in his process are good for him, then they will be good for us. So you can learn a lot from your customer. The customer can learn a lot from us. And we see that if you sit down with your customer, discuss the problems, come to a solution together, this is an excellent way for future business. And this is basically what is missing a little bit. And I'm not putting the finger to the analyzer companies, but the analyzer companies, they have an interest to sell analyzers. And they will tell you everything that you need to know about the analyzers, about the accuracy, about the interferences, about the Modbus communication and the auto calibration. And you know what? We will also do the conditioning. This is how much time they spent on the conditioning. And I'm not blaming them, because I understand that they have to move units every year. They produce thousands of systems and they have to sell these. So they cannot take the time to design a system on the customer application. So This is where for instance, your company can come in. You can design it on the application of the customer, selecting the analyzer the customer wants to have. So I see in our industry, I see the business for neutral integrators as something very good. Yes. They're not fixed to an analyzer. They're not fixed to a system they buy from the factory. No, they look at the application. They talk to the customer. They come with a solution. Starting point, go to this customer, solve his problems. Solve his problems, and he will get you the next order.
Correct. Good way of thinking. So what do you think, based on your experience, and you're a very experienced guy on this business, what would be a target or an average time, shelf life, a useful time of analyzing system if it's well specified and maintained? How many years should last a good specified system?
We should ask the analyzer companies. Analyzer companies will tell you, my analyzer works for average 15 to 20 years. So you should be able to get 15 to 20 years out of an analyzer system. But in fact, we see that after 12 years, customers start to investigate to buy a new analyzer system.
Okay.
This has nothing to do with the analyzer. This has to do with the system, the sampling and the conditioning. Maybe. If you do not design the system in the right way, your analyzer will not live to the full 15 to 20 years. And after you have repaired your analyzers 3-4 times, you start thinking as a customer, ooh, maybe it's time. If you have fixed your engine 3 times in a car, even if it's 6 or 7 years old, you start thinking about buying a new car.
Yes.
So what I'm trying to say is, if you really design the whole system in the right way, you can get this 15 to 20 years out of your system. Now look at the cost saving if we can add another 5 years to the lifetime of your gas analyzer system. That's incredible.
Yes.
But okay, unfortunately, nobody takes that into account at the beginning of the process when they have to purchase a system. So think wise.
Yes. So based on this idea of 12 years, industries are always changing, are always evolving, and production capabilities increasing. And how does this affect the sample conditioning over the SAMs? Is it something that it had to be reviewed on a yearly basis, or what do you suggest for a user that is operating a SAM systems?
Now, as I said, we are in a very traditional industry. Processes that were built 30 years ago are still being built today. Of course, there will be some new processes coming on, but basically it is still the same. And for us, even if there is a lot of changes in a process, even if there is a lot of changes in the pressure of the gas, in the gas composition, in the temperature, it doesn't really matter, because we will look at the temperature, and we will look at the pressure, and we will look at the gas composition, and then design it on these values. And so even if the processes are changing, it doesn't really matter. Look at the data and then come up with the right sampling and conditioning system, and it will work.
So let's say some sampling systems is designed for a XYZ pressure, temperature, and conditions. So the company change and increase the production or whatever. Is it necessary to take a close look to the conditioning system to actualize it?
Of course, I always try to talk to the customer. The example I just gave you for this cement industry, people will not start burning tires as secondary fuel. They will run this process on natural gas. But maybe we should ask the customer before we design a system, is there a chance that you might be changing to other fuels? Are you getting oil from different areas around the world? Are you getting gas from different areas around the world? Because it can happen that there is more sulfur in this gas than in another gas. And so we should investigate in new systems already in the beginning, what alternative fuels can he possibly use? And then we could take that into account. A very simple thing is that in gas analysis, you use heated lines to prevent condensation to transport gases. Now, the cheapest and the easiest is to use a self-regulated line. You buy it for, let us say, 120 degrees C, and it will be heated to 120 degrees C, what basically is enough. You are above the dew point of your process as it is. But what happens if you in the future are changing your fuel, if your process is changing and your dew point goes to 140? Now you get condensation in this heated line. So if there is a possibility for the customer to change his process, maybe add some processes to it, I always advise maybe we should go to a temperature regulated line. And you can set the temperature between 0 and 200. You set it to 120 now, but if needed in the future, you just set it to 140, 150, and you can still use the same system. So talk to the customer, discuss the possibilities. Is there a possibility for them to add new processes, change fuels? Then take that into account in the design of your system.
Yes. So people that are watching us from home, it's very important that both engineering firms, the companies that are designing, and mostly the user, because the user is the person that is on the day-by-day business, have in mind that every time that you change something on your processes, maybe it's time to have a close review of the SAM systems.
Sure.
Yes.
And we are there for that.
Okay. So guys, thank you very much for your time. Thank you, Marcel, again for coming over.
No problem.
It was a pleasure. And hopefully we talk with you soon for some of our customers' needs on conditioning systems.
Sure. Thank you very much for the invitation.
Thank you, guys.
Thank you. Bye.
Bye.